Hello friends, it's Lagrange here, and today we're gonna solve this question. Here you see a particle of mass m is projected with initial velocity u at an angle alpha with the horizontal. Use Lagrange equations to describe the motion of the projectile, and resistance of air is neglected in this case. So note the question. So before we start, please do subscribe the channel, help me to grow my channel, inspire me to create new contents for you, and do share with your friends, and also hit the bell icon so that you get notified when new video will be uploaded, right? And also hit the thumbs up button, right? So now let's start. This is an object of mass m, or this is a particle of mass m, suppose, and it is projected in this way, and here is the horizontal axis, that is x-axis. Here this is the x-axis and this is y-axis. Suppose this is y-axis, right? And it makes an angle alpha with the horizontal, that means with x-axis, right? With x-axis. Now you see it is projected with initial velocity u. It is projected with initial velocity u, and its motion should be like this, right? This way, right? It is two-dimensional motion, right? So now here, so this is the origin, and mass of this particle is m, right? Mass of this particle is m. Okay, now the particle of mass m is projected with initial velocity u, and angle of projection with x-axis is alpha, right? Now see, this velocity must have two components. That is, one is this, that is x component, ux, which must be, if this angle is alpha, then this component must be u cos alpha, and its y component should be this should be y component, that is uy, which is u sine alpha, right? Okay, so hope you have understood this, right? So ux, or you can write x dot means dx by dt, which gives the velocity along x-axis, right? So similarly, y dot is velocity along y-axis. So here this must be equal to u cos alpha. Similarly, y component of its velocity, that should be y dot, which is equal to u sine alpha, right? We can consider that. Now in order to use the Lagrangian, we know Lagrangian L is equal to kinetic energy minus potential energy. So let's find the kinetic energy now. So kinetic energy T, that's going to be equal to half m, as we have two velocity components. So here x dot square plus y dot square, then potential energy V, that's going to be equal to, now you see it will possess potential energy due to the height along y-axis, right? So that's why if at any position at any time t, suppose this is its coordinate x comma y, then its height is now y. In that case its potential energy will be given by mgy, right? Mgy, right? So therefore the Lagrangian L is equal to T minus V, and that's going to be equal to half m x dot square plus y dot square, x dot square plus y dot square minus mgy, right? Now you see, we know the Lagrange equations. For the x component, we're gonna write del L by del x minus time derivative of del L by del x dot, that's equal to 0. And for the x component, for the y component, this is for the x component. Now for y component, del L by del y minus time derivative of del L by del y dot is equal to 0. That's what we're gonna have, right? Now you see, if you differentiate this with respect to x, here you see we have x dot, and we don't have any term containing x only, so that's why this must be 0. So that's why del L by del x, that's gonna be equal to 0, minus time derivative of del L by del x dot. If you differentiate it partially with respect to x dot, then you see this y dot square and y term containing y dot square and y gonna be 0 time derivative, partial derivative with respect to x dot, and we have to differentiate this part only. If you differentiate x dot square with respect to x dot, then you should get 2x dot, and these 2 will be cancelled with this, right? So what we're gonna have, mx dot is equal to 0, right? Now this means minus, if you differentiate it with respect to t again, then it's gonna be x double dot, which is equal to 0, and this implies, if you divide both sides by minus m, then it implies x double dot is equal to 0, right? X double dot is the acceleration along y-axis, so that means there is no acceleration along y-axis. That means ax is equal to 0. Okay, acceleration is taking place along y-axis only, right? Now from this equation, we're going to apply the same method. If you differentiate this L partially with respect to y, here only one term containing only y, that is this mgy. So here we're going to have minus mg. If you differentiate this y with respect to y, that's going to be 1 into minus mg, right? Then minus time derivative, and if you differentiate it with respect to y dot, then x dot should be considered as a constant, y should be considered as constant. We have to differentiate partially with respect to y dot, then it's going to be half m 2y dot, so 2 will be cancelled. So again here we're going to have m y dot is equal to 0. So this minus mg, so minus, if you differentiate it with respect to t again, then you're going to get m y double dot, right, is equal to 0, and divide both sides by minus m, then you're going to have g plus y double dot is equal to 0, right? G plus y double dot is equal to 0. Now you see, from here we can write y double dot is equal to minus g. Y double dot is equal to minus g. That means the acceleration along y axis is acceleration due to gravity, which is minus g because it is downward. Right? So these are the two Lagrangian equations of motion for this projectile motion. But if you want to know the path, what kind of path it is taking, then you have to find the equation of the path. Then how to find that? Let me show you. Okay, so first copy these things, note these things. I'm going to clean the board. Okay, just let's do one thing. Let's take this question, take this equation number 1 and take this one as equation number 2, this one as equation number 2. So y double dot minus z is taken as 2. Let me take this one as 2, equation number 2. So you see, now you see, let us take the equation number 1. From equation number 1, you see, we are getting x double dot is equal to 0, right? X double dot means, you know, dx dot by dt, right? So instead of differential coefficient, we used to put dot here, right? Is equal to 0. So which means if you integrate it, so you know, ddt of x dot is equal to 0. That means x dot is equal to, that must be a constant, right? That must be a constant, and that constant will be equal to, you see, x dot is u cos alpha, because why it is constant, as along x-axis acceleration is 0, right? So that's why the x dot, which is velocity along x-axis, that is u cos alpha, that must be constant. There is no acceleration along x-axis, right? U cos alpha. Now you see, x dot can be written as dx by dt is equal to u cos alpha. Now therefore dx can be written as u cos alpha dt, right? If you integrate both sides, then what you gonna get? X is equal to u cos alpha. This is not a function of t, we are integrating with respect to t, right? And if you integrate dt, that's gonna be equal to t, and we're gonna end up with a constant that is, suppose, let me take this as c1. Okay, that is the integrating constant. So what will be the value of this integrating constant? Now you see, at time t is equal to 0, x must be also equal to 0, because at t is equal to 0, the particle was here, so distance travel along x-axis is 0, right? So in that case, from this above equation, if you put 0 here, then this implies c1 is equal to 0. Now put the value of c1 here, then we're gonna get x is equal to u cos alpha into t, and which implies that t is equal to x by u cos alpha. That's what we're gonna have. Now you see, let me take this as equation number 3, right? Let me take this as equation number 3. Now just note this, pause the video and note these things. I'm going to clean this board. Now you see, so I have cleaned this board. I have written only those equations which we have obtained and which we are going to use. Okay, and Lagrange, from using the Lagrange equation, we have got these two equations of motion for this motion, right? Now I'm going to obtain the equation of this part, right? So how to do that? Now from equation number 2, it implies that first let me write equation number 2 as it is, y double dot minus z, and that means time derivative of y dot is y double dot, right? So let me write this one as y dot is equal to minus z, and that means y dot dy dot, sorry, dy dot, that's going to be equal to minus z dt. And if you integrate this equation, then z is constant, that should be taken out, right? That's going to give you y dot is equal to minus z into t. There must be integrating constant. Let me take is c2 because we have already used c1, so let me take this is c2, right? So now you see this c2 is integrating constant. Okay, c2 is constant, integrating constant, hope you know. And now you see at time t is equal to 0, if you put t is equal to 0 here, this equation imply this implies 0 plus c2, which means y dot is equal to c2, and y dot we know that u sine alpha, so which means here we are getting c2 is equal to, so here we can write y dot, so here we're going to get c2 is equal to u sine alpha, because y dot is equal to u sine alpha, right? So now let's put this value of c2 here. Therefore we end up getting y dot is equal to minus z t plus u sine alpha, and this can be written this way: dy by dt minus zt plus u sine alpha, and also we can simplify this way: dy is equal to here dt and dt. Now if you integrate this is t, z is constant, can be kept outside. If you integrate this, then what you're going to get? So here you're going to have y and minus, so integration of t dt, that's going to give you t square by 2, then plus u sine alpha, and integration of dt is t, right? And again we're going to get a constant, let it be c3. Okay, so now you see, if you put t is equal to 0, then if you put t is equal to 0, this two terms going to be 0, and this y going to be is also 0, right? Okay, t that y is the y going to be equal to 0, right? Then from this equation we're going to have, from these conditions, this is 0, this is 0, this part is 0, so that means c3 is equal to 0. This implies c3 is equal to 0, and if you put the value of c3 here, then therefore what we're going to have, y is equal to minus z t square by 2 plus u sine alpha t. Now here we are going to use this equation number 3. That means we're going to replace the t, this t by this value of t, and doing so what we have got, y is equal to minus z, let me write the half outside, let me write the half here. Okay, t by 2 is there, so instead of t we're going to have x is t, instead of t square, x square by u square cos square alpha, right? Cos square alpha, and here plus u sine alpha instead of t, x by u cos alpha, that's what we're going to have, right? And sine alpha by cos alpha, here u cancel, sine alpha by cos alpha, that's going to be tan alpha, so that's why this equation becomes y is equal to tan alpha and let me write the x here. So we can write x tan alpha, y is equal to x tan alpha minus half z, or you can write minus x square by gx square by 2u square cos square alpha. You can write this. Now you see here the degree highest power on x is 2, so it is quadratic, so it must be the equation of parabola. Therefore the path is parabola. The path of the projectile is a parabola. Right? So hope you have understood this. See you in the next video. Bye bye. Take care.